Hello teammates, it's Mr. Nitty coming to you with another exciting free response question solution brought to you from the physics bunker. I lost my original sign. Now I've been at my kitchen table since about 7 o'clock this morning. It's now 6:30 in the afternoon. I have not really left this table, but I'll be daggum if I can find my physics production sign. And that's a historical document. I gotta find that. Anyway, that's not gonna slow us down. Let's take a look. And I printed it kind of funky. I'm not sure why it came out like that. It's one of them days. So it's a uniform circular motion problem. And pretty much that's all it is. And it looks kind of intimidating when you first look at it. And I bet even amongst my oh so brave AP Physics 1 students, I bet I had a few eyes roll the back of the head, lose your will to live. But if, like anything in AP, if you just take it by the numbers, you're going to be okay. If you panic, it's going to be like your 45-minute experience in the exam is going to be like the last 45 minutes of Titanic. So you got a book sitting on a bench on a Ferris wheel. We don't care why the book is there. We're given a graph, and let's dive in. Determine the period. Easy money. I'm going to do it right here. Period is one repetition of the waveform. You can go peak to peak, trough to trough. I'm going to go from here to here because that seems the easiest to do. It starts at 0. Waveform repeats itself right there. Starts to repeat itself. Then you got to be careful when you read your graph. You're gonna read. So it's not by tens, is it? It's by 20s. So be careful, right? Remember the Richard Feynman technique. The key to physics is not getting fooled, and you're the easiest person to fool yourself. So period is 120 seconds. I'd keep it in seconds. The second question, determine the tangential speed. So you gotta find some evidence. If you just look up here, you're gonna go, well, wait a minute. Tangential speed is essentially going to be change in x over time. And you know, for something moving a circle, 2 pi r over period. But where's my r? It's right here. So it's giving you the period as it goes up and down, or left and right. Right? It's all going to be the same. Left and right. It looks like your radius is 30 meters, teammates. So as it goes, it looks like they're doing this in the x direction. So if it's at 0, and so it's a 0, and it's going to move in the negative x direction till you get to 30 meters right there. And there's your R. So look for it. You are going to find every question is solvable as long as you don't panic and you look for what you got. So velocity 2 pi r over period, that's actually pretty much on your equation sheet. And you know that as well. Take it by the numbers. No miraculous solutions. 2 pi r over period. Plug in your values, 2 pi, 30 meters over 120 seconds, gives you a tangential velocity of 1.6 meters per second. You are in the money. That was 3 points. Part B, on a dot below, draw a free body diagram. So you got your dot, you know, uniform circular motion, your net force is going to be up, so your normal force is going to be greater than your FG. Draw it so it's obviously greater. You can even write greater than FG. You sure can write that. And you know, yeah, you don't even have to explain it. That's 3 points. 3 points. You're going to identify your normal force, your force gravity, and your force normal is greater because your centripetal force is towards the center. 3 points. No extraneous forces. Nothing like this, teammates. Don't draw anything like this. Don't draw anything like that. You're drawing forces. You're drawing forces. The acceleration is towards the center, not tangential. BWI, the circular path book, is moving only in the horizontal direction. What direction is the net vertical force? So the trap is, it's moving in the horizontal direction, so acceleration must be no. You know it's uniform circular motion. You're going to write it's up, and you're going to explain this is uniform circular motion, excels towards the axis of rotation. Thus, force net must be towards the axis of rotation. Teammates, the College Board has caught on to claim evidence reasoning. I didn't do a terribly good job there, but claim is up, and then Y, state your evidence and reasoning. They like this. They like this. If you see their examples, they are down with claim, evidence, reasoning. Let's go to part C. Derive an algebraic equation for the vertical forces the bench exerts. You're going to walk the dog. Net force equals MA. Net force in this case equals mass times the triple acceleration equals mass velocity squared over R. Right? So your net force, your force centripetal, your force centripetal, your force centripetal. Net force, now we're going to put our variables in. I'm going to walk the dog here. They like you to do this. They don't want to see mass. They want to see mass of what? Mass of the book. Give them what they want. Mass of the book, velocity of the book over R. I should put a capital R here. I'm very sorry. So net force, mass B, velocity B squared over R equals, so that's your net force, equals force normal minus Fg. Force normal is your greatest force. I'd put that first. You're going to have net force up, force normal minus force gravity. Take this step. Then here, isolate your force normal. Force normal equals your centripetal force plus the weight. Right? So what I did, I left normal there. I added Fg to each side. You can do this. Now's the time to do that. You could have done another step and done a variable there. But get to here. Get to mg. Nope. Variables, a label of a force is not a variable. Now, the College Board loves this. Right? This is the distributive property, isn't it? So I can factor out MB. And that's an MB. I can factor out MB times VB squared over R plus G. If I multiply, I'm going to get the exact same thing, won't I? College Board loves to factor stuff out and use that distribution law. Show them what you are made of. Next. Lowest point in the circular path is the force the bench exerts on the book greater than? You know that force is greater than. Here's a trap. Because maybe you reasoned that the Ferris wheel is moving at a constant speed. And you're going to say, well, constant speed, no acceleration, forces are balanced. You got centripetal force, you got centripetal acceleration greater than. Claim, evidence, reasoning. I tried to do a better job on this. Claim the lowest point, the force of the bench exerts on the book is greater than the weight of the book, right? Evidence, direction, net vertical force is up. And you can do this. C part B double I. Don't just put E, C part B double I. You can do this. So direction net vertical force is up as I showed there. So make it into a sentence. Reasoning. Force normal must be greater. So net force is up. Magnitude of force is up. And then come back to this equation too. They'd like for you to do that. As I showed, mb times vb squared over r plus g is greater than mg. Absolutely. And I should have put mbg. Absolutely. You can see that. Hot diggity dog, teammates. Have you a great day out here.